Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly challenge, third question. So this is about destroy sequential targets. So here you can see that you are given a zero index array nums consisting of positive integer representing targets on a number line. You are also given integer space. So basically nums array is being given to us and one integer space is being given to us. Now let us take role of these two things. So here you have a machine which can destroy targets. Seeding the machine with some nums of I allows it to destroy all the targets with value that can be represented as. So all the values in this particular nums of basically this nums array could be destroyed. And how it could be destroyed by seeding a particular value nums of I means basically we are required to figure out with that nums of I value which can help us to destroy maximum elements from this nums. So that is the thing. And how it can destroy maximum element, it is on the base of this. Means the space multiplication with some arbitrary integer and then adding that up to the nums. So that's the thing it would be there, where C is any non-negative integer. You want to destroy the maximum number of targets in the nums. So that's the thing. Means basically, we are required to choose one integer from this particular input which is being given to us. And this particular integer which we are going to choose, that is required to complete up this particular formula. And on the basis of this formula only, we will be figuring out one element. And that element would be destroyed from this particular array which is there. So now let me just first try run with the same and then you will be able to figure out that what exactly this question want to say. So 1 minute. Yeah. So here you can see this nums is given to us. Let us choose that nums as this one. That is 3. So space is given as 2, right? And now according to this formula, 3 plus, let us first put this C as 0. So space into 2 would be 0, right? So what is that element? That is 3. So our 3 would be destroyed from this particular place. If you see that if we seed the machine with nums of 3, then destroy target equal to this. That's it. I'm just taking example. So we have chosen this 3, right? So we destroyed one element. Now we go ahead with this formula. For this particular 7, what is the nearest which we can make spaces to, right? So 3 plus, if 1 is there, 2, that would be 5. Then 3 plus 3 to the 6, right? So 6 plus 3, that one will be 9. And here we see that no more element is there. So 5 would be destroyed and 3 would be destroyed, right? So we will be getting elements. 2 element would be destroyed if we choose 3 as our nums of 5. Now let us choose next element, that is 7. So we choose 7. So 7 plus 0, it would be 7. So 7 would be destroyed. Then 7 plus 2 into 1, that would be 9. And we can't find any number as 9 here. So that's why here we got that with 7 we can just destroy one element. Now come to the next part. Here it is for 8, and 8 is much more bigger than 7, so you can see that it won't be able to destroy anymore. And then here we are having this 1. So then 1 plus 0, that is this 1 would be destroyed. Then 1 plus 2 into 1, that would be 3, right? So this 3 got destroyed. Then 1 plus 2 into 2, that is 4, so it will be 5. So this 5 got destroyed. Then 1 plus 3 into 2, that is 6, that is 7, so 7 got destroyed. Then 1 plus 4 into 4 into 2, that is 8 equals to 9. So here we don't have 9. So in actual, we were able to destroy basically 5 elements. So this was till now the biggest number of elements which we were able to destroy. So this was what we are required to do in this particular question. So this was about the explanation of this question. Now let us check for the constraint and then we will be going at that how we are required to do this question. So here constraints are like that this particular nums array that could go up to 10 raised to the power 5. means elements in this particular nums would be up to 10 raised to power 5, and each element can go up to 10 raised to power 9, and the space that also can go up to 10 raised to power 9. So from this, so if we check here the solution which we can devise ahead is on the basis of what element is there in between this and what is there for the space which is being given to us. So according to that, we are required to check for the solution here. Now let us go ahead. Let us check for nums and the space. So now when we check for all these things, so here the thing would be this nums which is being given to us. So if we check for the maximum element and the minimum element, means basically a range of element we pick up as per on the basis of remainder, and that remainder we will be getting according to this particular space. And why I'm saying about this particular thing, see, what we are required to do is means whatever nums is there, so whatever nums is there, so that would be added to the space, and the space is basically multiplied with some arbitrary integer, right? So here, if you check that remainder plus quotient into dividend, divisor equals to dividend, the formula which is being there. Now, if we go ahead with the same, and then we check for this, that if we check for similar remainders, right? So whatever which is there means whatever element which is being there. So see, if we do divide it by 2, right? So we will be getting remainder as 1. If we divide it by 2, then what remainder we will be getting? So that would be 1, right? If we divide this particular by 2, then we will be getting 0. This by 2, then it will be that remainder. That will be 1. Here also it will be 1. And here also it will be 1. So now in all of these, if we check, all are having same remainders. And then we check out that what is the maximum number in all these which are having the same remainder, and what is the minimum number which is having the same remainder, right? So in that context, the thing would be uh, that we will be getting a particular range, and from that particular range only, we can easily able to determine that this is the possible maximum possible numbers which could be completely tracked down of this particular nums array which is being given to us. So in that context only, means when we are able to figure out that what is the maximum element which we could remove, and now comes the part for it, because we are required to return the smallest one, because when we are going ahead with the smallest one, we will be multiplying it with something, means adding it some with something, and whatever we are adding that is being given to us here, and this particular is also multiplied with some other arbitrary integer, and because of that only we will be able to eliminate the elements out of the num array which is being given to us. So that's why we will be choosing the smallest one, and that's why going on the same line that all the remainders are equal, maximum element which is being there and the minimum element which is being there, so we will be returning that minimum element as our answer. So that would be the thing here. So now comes the part that what would the coding solution for the same. So here we are going ahead. We will be storing all our whatever remainder, and corresponding to that whatever would be there, we will be storing here in this particular map, so that we could easily map them and get our final result. So here the thing is that this answer, because we require minimum element, so we are just initializing with int max. This max with the int min, because we want the maximum element, and corresponding to that we will be comparing with this int min. Now here we are going ahead with checking for all those remainders where means we are checking for each element's remainder, and corresponding to that we will be figuring out that what is the maximum element which we can get because of that remainder. So here we are checking remainder of that particular. with that particular space which is being given to us. And then we are directly, what we say means directly putting that particular into our map, means that remainder which we obtain, and corresponding to that number of elements would be put like this only, that these were the maximum number of elements which we figured out. Then here we will be checking that corresponding to this particular remainder, what was the actual count which we got. If it is greater than our maximum count, then uh, we will be updating our maximum count with this particular. And because of this only, we will be able to figure out the maximum numbers which we could easily terminate from this particular nums which is being given to us by taking a minimum number which is of that particular remainder. Now in this particular array, what I'm saying, now we are iterating this particular nums again to get our minimum number. So here we are checking with that particular thing again, means checking for the remainder part, that if at particular moment, if that maximum is equals to the remainder, means the count which is corresponding to that particular remainder, because here what we are doing is we are just checking for that remainder, and then corresponding to that remainder whatever count is there, and then maximum which was earlier stored here, right? If they are equal, then whatever minimum we get, that would be our answer. So the thing is that what we are doing here is we are basically mapping, you could directly say is a hash. So we are basically hashing, we are basically hashing this particular what we say as remainder, and corresponding to that the count which is being there, that we are doing. And because of this thing only, we will be getting that whatever remainder is there, that how many total elements which are there, means this count is basically corresponding to this number of total elements. So that we are checking because of this hashing thing. So that is the first thing which we are going ahead with. So whenever we get a particular count which is equal to the total element count of this particular remainder, so corresponding to this remainder only, we will be moving ahead, and then we will be checking that what is the minimum element from all those elements which we were taking, means the example which was there 135871, right? And the space was 2, space was 2, right? So when we do modulo with all of them, right, except this, here we get 0, but for all of them we are getting 1, right? So it will be checking that whatever remainder which is being there. So out of all of these, what is that particular element which will be having the remainder equals to 1? Means here we got this one as the minimum element, and that's why we will be returning that particular as an answer. So this was about the explanation part of this particular code. Now comes the part for the time complexity and space complexity for the same. Here we are using this unordered map which is order of 1, because we are just what we say, just looking up in this particular hash map which is being there, and then traversing this particular nums which is being there one time, then traversing it second time, right? And other operation which we are doing inside, that are already order of 1. So that's why the overall time complexity of this particular solution is um, order of n, where order of n simply refers to the size of the array which is being given to us, and that array is basically input array. Now the space complexity, we are using this unordered map. A number of elements, say it is n, so that's why space complexity becomes order of n. So this was all for this particular solution and this question. If you have any doubt, you can comment it down, and if you are new to channel, then you can like, subscribe, and even share among your friends. So this was all for the same. So yeah, thank you.